In this video, we're going to discuss common factors of algebraic expressions. We'll also learn how to identify the greatest common factor of a set of expressions. And lastly, we'll factor out the greatest common factor of a simple polynomial. So let's get started. In this first part, we're told to break the expressions 10x cubed y squared and 12x y to the fifth, so those two expressions, we're told to break those down into individual factors, expanding things like x squared into x times x and 15 into 3 times 5. We're then asked what factors are common to both expressions. So if we break down 10x cubed y squared, as we're directed to do so, we're really looking for these prime factors. So 10 can be broken down into 2 times 5, so I'll write 10x cubed y squared equals 2 times 5, and then I'm going to expand that x cubed into x times x times x. And this will help me visualize that x cubed is really representing the factor of x 3 times. Then on the end, that y squared, I'll represent that with y times y. So I've written 10x cubed y squared equal to 2 times 5 times x times x times x times y times y. Again, that factor of x occurred 3 times, and the factor of y occurred 2 times. Now we'll go to the second expression, which is 12x y to the fifth, and I'll break it down in a similar way. So 12, if I break it down into its prime factorization, is 2 times 2 times 3, so I'll write that, 2 times 2 times 3, and then x, I just have one of them, so I'm going to write that as times x, and then y to the fifth is the factor of y occurring 5 times. So I'll write times y, times y, times y, times y, times y, and again I wrote that factor of y 5 times. Now, if I look at what factors are common to both expressions, I can see that numerically the factor of 2 is common to both, and as far as variables go, I have a factor of x, but just once, common to each of them. In the first one I have 3 factors of x, but in the second I only have a single factor of x. So only one factor of x is common to both of those expressions. Lastly, I'll look at the factors relating to y. And so in this first expression, I have a factor of y twice, and I also have a factor of y twice in the second expression. So looking at what's common to both, I have 2 times x times y, which is of course written as 2xy squared. This is what we're going to refer to as the greatest common factor. So it's the most that can be factored out of each of those expressions. And when we say greatest common factor, it has the common factors, but it has all of them included. So if I'd only included, for example, one factor of y, that wouldn't be the greatest common factor because 2 factors of y were common to both. This is often written as an acronym capital G, capital C, capital F. So our next question is, what does the acronym GCF stand for? And that's greatest common factor. All right, so in this next part, we're going to find the GCF of the list of polynomial terms. So we have a couple sets here. This first one has 24t cubed and 18t squared. Now, we can go through a process as formal as we started with, but in general, we're going to look at the numerical coefficients of each of our terms, and then we'll look at the variables and look at the exponents and deduce what the greatest common factor is. So with these two, I have 24t cubed and 18t squared. With 24 and 18, I know that numerically, the greatest common factor there of 24 and 18 is just going to be 6. And then between t cubed and t squared, the smaller exponent, which is a 2, is common to both. So 6t squared is the greatest common factor of those two expressions. Looking at our next example, we have 3x and 12y. Just looking at the coefficients, 3 and 12 have 3 as a common factor. When I move to the variables, though, I have x to the first power on the first expression and y to the first power on the second expression, so they don't actually have any variable factors in common. So the greatest common factor of this term 3x and 12y is simply 3. Looking at the next one, I have 2x squared, 3x, and 4. And so as I look at the coefficients, 2, 3, and 4, their greatest common factor is simply 1. I don't actually have a common factor other than 1 for those coefficients. And then looking at the variables, I have x squared, x, and then I just have a numerical constant. So I don't have a variable factor common to those. So when I look at the GCF here, it's simply 1. I don't have anything other than 1. All right, and lastly, we're going to look at the expression 2x plus 10, and we're first asked what is the GCF. And then we're asked how can this polynomial be factored. So in order to factor this, or to break it down into its factors, we need to identify the GCF, and then we'll factor it out. So the GCF, and we'll look at of the terms 2x, so the GCF of 2x and 10 is simply 2. Looking at 2 and 10, they have 2 as a common factor, and that first term has x, and the second term does not have x. So when I factor it out, we'll factor out 2. So what this will look like is I'll take 2x plus 10, and then I'm going to factor out a 2, so it now becomes a factor times something else. And so as I look at that, 2x is 2 times x, so when I factor out a 2, I'm simply left with x. And then I had plus 10, so when I factor a 2 out of that 10, I'm left with 5. So 2x plus 10 is then equal to 2 times that expression, x plus 5.